In this video, we're going to be solving some more word problems. So let's get started. Let's say Peter studies for 3 hours. Peter studies 3 hours. And he reads 60 pages. In 3 hours, he reads 60 pages. How much time did he spend on reading one page? Okay, so let's set up our equation here. Let's let t equal time, and more specifically, the time to read one page. That's what we want to solve for. Time to read one page. Okay, he read 60 pages in 3 hours. We want to know how long it takes him to read one page. So how we can interpret this is 3 hours is 60 times the time it takes to read one page. So we can set up our equation as 3 hours equals 60 times the time it takes to read one page. Okay? He read for 3 hours and read 60 pages, so we want to know how long it takes him to read one page. So 3 hours is 60 times the time it takes to read one page. Okay, so here's our equation, and we simply solve it straightforward like. Alright, how do we do this? We isolate our variable and have everything else on the other side. So let's go ahead. T is being multiplied by 60, so let's go ahead and divide by 60. Do the same on the other side. 60 and 60 cancel, so we only have t on one side. On the other side, we have 3 divided by 60, which is 1 over 20. Okay, and this is time given in hours. So let's go ahead and convert this to minutes, because we don't want to leave our time given in 1/20th of an hour. So let's go ahead and convert to minutes. 1/20th of an hour, and there's 60 minutes in an hour. So 60 times 1 over 20, or we can write this as 60 over 20. And this equals 3 minutes. So it takes 3 minutes to read one page. Okay? Let's do another one. Let's say after a 15% discount, a phone costs $100. So we're buying a phone that costs $100, and that's after a 15% discount. How much was the phone before the discount? That's what we want to find out. So let's define a variable p. And this is going to be the price before the discount. Price before discount. And this is what we want to solve for. We want to know the price before the 15% discount. So let's set up our equation. We can interpret this as the price, P, minus 15% of the price is $100. So the price P minus 15%, or 0.15. So 15% of the price, so we're going to multiply 15% times the price, equals 100. And here's our equation. So we have the original price minus 15% of the original price will give us $100. So we want to find out P in this. So we have 1P minus 0.15P, which will give us 0.85P equals 100. Okay, now we simply divide both sides by 0.85. That'll cancel that out and get P all by itself. And 100 divided by 0.15 will give us 117.65. This is in dollars. Okay, so the price before discount is $117.65. We have to take a 15% discount, and the sale price is $100. Okay, so be sure we figured out. Be sure you understand how we got this equation, because that's the most important part in a word problem, is actually converting it into an equation. Let's do another one. Let's say we have some apples. Apples cost let's say 30 cents each. And these are for apples. Apples. And let's say we have some oranges that cost 50 cents a piece. 50 cents for some oranges. Okay, let's say Colt buys twice as many apples as oranges. Okay, and his total bill is $11. We want to know how many apples and how many oranges did Colt buy. Okay. Well, in our word problem, since we're comparing apples and oranges, the way we're comparing it is, well, we have twice as many apples as oranges. So we want to define our variable in terms of oranges, and I'll show you why in a second. We're going to let x equal number of oranges. Okay. So we have the price of an orange. We want to know how much we spent on oranges. So the price of an orange times the number of oranges is going to give us the total spent on oranges. So we have 0.50, or just 0.5, times x will give us the price of oranges. Now we want to know the price of apples. So the price of an apple is 0.30, or 0.3, times the number of apples. Well, how many apples do we have? We have twice as many apples as oranges. So we have 2x apples. Okay, this is why we wanted to define our variable in terms of oranges, because we have the number of apples defined in terms of oranges. We have twice as many apples as oranges. So let's be sure we think about this and why we defined our variable in terms of oranges, and make sure we understand that, because that's very important when we're setting up an equation. And all this is going to equal $11. $11 is our total. So now we have an equation that we can work with. So let's go ahead and isolate our variable and solve for x. Okay. So we can rewrite this. We have 0.5x. And go ahead and multiply this. This will give us 0.6x. 0.3 times 2x is 0.6x equals 11. Now we can combine these two terms. 0.5x and 0.6x equals 1.1x equals 11. We're almost done here. We're going to divide both sides by 1.1. That's going to isolate our variable x. So we're going to have x on this side, and 11 divided by 1.1 gives us 10. So x is the number of oranges, and x equals 10. So we have 10 oranges. And what was our original question? We want to know how many apples and how many oranges did Colt buy? Well, we have 10 oranges, and we know that the number of apples is twice the amount of oranges. So to find the number of apples, we simply multiply the number of oranges by 2, because we have twice as many. So 2 times 10 equals 20. And this is the number of apples. So Colt bought 10 oranges and 20 apples. Okay, and we can also check this by plugging in 10 for x for this x and 20 for this x. Make sure we plug them into the right places. And just want to remind you the importance of checking our answers, because we should never get an equation wrong, because we can always check it. Okay, let's go ahead and do one more. Let's say the cost of a Kubota tractor, which is a pretty popular tractor, is 60%. A Kubota, say Kubota, is 60% of the price of a John Deere tractor. If the price of a Kubota is $12,000, $12,000 for a Kubota tractor, what is the price of the John Deere tractor? Okay, so let's set up our equation. What do we want to solve for? Let's say P equals the price of a John Deere tractor. So we want to know how much a John Deere tractor costs. Well, we have a relation here that says the Kubota is 60% of a John Deere tractor, and we know the price of a Kubota is $12,000. So if a Kubota is 60% of the price of a John Deere tractor, we have 60% or 0.6 P. A Kubota is 60% of P, which is the price of a John Deere. And this equals $12,000. Okay, be sure we understand how we got that. Because now that we got the difficult part solved, or the more tedious part, we can actually go about solving our equation. We can divide this by 0.6 to cancel out and isolate our variable. We have to do the same thing on the other side. And this gives us P equals 12,000 divided by 0.6 should be $20,000. $20,000. And this is the price of a John Deere tractor. The Kubota, which is 60% of the price of a John Deere tractor, is $12,000. Okay, so what do we learn here? Well, when we're converting word problems to equations, we want to be sure we're looking for keywords. And we don't have to write out the word problem. We can just single out the keywords here. Or if we write out the word problem, we want to underline them. And we want to make sure that we write out the equation properly. We want to define our variables to where it makes writing the equation simpler. Okay, so be sure to go over these several times just to make sure we got a good handle on it, and I'll see you soon.